Yes, thank you. Welcome, ladies and gentlemen. My name is Riccardo Zanchetta. I work for BtomHLER UDDEHOLM Italy in the UDDEHOLM division. And today I will present you our point of view and our state of the art regarding the forming of advanced high-strength sheets, mainly in the automotive industry, both with the two alternative techniques of the cold and the hot stamping. Few words about UDDEHOLM. UDDEHOLM is a tool steel producers based in Sweden. Is a part of BtomHLER UDDEHOLM group, which is a branch of the Austrian voestalpine company. UDDEHOLM is a partner of ISTMA worldwide, and the main of our feature is to produce tooling materials with a great mix of properties to solve a lot of problems and to cover all the needs for many applications. Another additionally property of UDDEHOLM is to give services and the possibility to give support and assistance on a lot of factors influencing the tool life. So try to optimize as much as possible the tool performance is our important aim. Another important feature is that we are a worldwide company. We are a global support. So the good thing is that we can offer our services and knowledge everywhere in the world. So, for example, if your end customers or your supplier is very far from here, is everywhere in the world, we can support him exactly in the right way where we can do how we can do here in Europe. Let's start with the trends. As you well know, in the recent years, the trend in the automotive industry is to reduce emissions, of course, for environmental reasons. And on the other hand, for safety reasons, materials used for the frame and for the body, the car body, must be stronger. Which are the advantages of advanced high-strength sheets? Are to have both the properties, to be light as thin sheets and to be strong. The problem is that to form this type of materials is rather complicated due to very high stresses on the tools. And so how to solve these problems? Let's start with the cold work. This is an example. In this chart you can see the tendency in the years to increase the yield strength in megapascal of the high-strength sheets to increase this possibility to have lighter components and strength. Now, in the recent years, we can easily go over 1,200 megapascal, and we also can see a lot of new materials running in this area, so with a very high yield strength and also with a very high elongation values. These are some examples for blanking, where we can see that just changing the strength of the steel, the produced steel, the force of the press during the blanking is totally different. So this is one important aspect to consider. And regarding the design, these are two examples on how changing the die clearance between the punch and the edge, you will have a totally different result. So our approach is to know all these aspects and to help the customer to take the right decisions on all this area. Also using finite element programs for bidimensional and also three-dimensional shapes. We can simulate forming and blanking and give to the customer suggestion to reduce contact pressure, for example, in some special areas with the use of the right material, the right heat treatment, the right surface treatment and finishing, and maybe changing sometimes the design. Sometimes it's the only choice. Change a little the die radius, for example. UDDEHOLM approach is to start from the dominant failure mechanism. Since many years, we are developing tooling materials to support these high stresses, form these new sheets. And so, starting from the standard version of 1.2379 steel, which for us is the base of the cold forming, cold stamping. We can, as you can see, we can go in the direction of the increasing abrasive wear resistance with materials like Caldice, Leipner, Vanadis 4 Extra, if the abrasive wear resistance is the main problem. In other cases, we have dominant adhesive wear, which is totally different behavior. And so in that case, we can go with materials that gradually increase this property. Then we can have plastic deformation, especially with complex shape and with very hard materials to be transformed. And then we can go increasing the compression resistance. And then the same for the chipping resistance and for the total breakage of the die. This scheme, you can see it also in the brochure that are in our UDDEHOLM stand, is exactly the same. How to support, how to optimize? As we said before, UDDEHOLM is known to not just deliver the material, but give the total support on many other aspects influencing the tooling life and tooling performance. Which are these aspects? Are tool design, tool material, the right choice, the right heat treatment, and the right tool production, means of manufacturing of the die. These are just an example. All of these are, we can see them as chains, rings on a chain, and of course all these rings must be tough and not break. Otherwise everything is bad. We normally represent this global economy of the tooling as an iceberg. So the biggest part of the cost of a tooling is below the water as a real iceberg. And if we see which cost is, these are all the repairs, the stop in production, the adjustment, the delays in delivery, welding, and everything which make the production very costly. The part in this area, so is the minimum part, is the cost of the production of the tool. And a percent of roughly 15% or 20%, depending on the tool, is represented by the cost of the tool steel. So the big point is optimizing this area with the right tool steel, but also with the right other aspect, considering all the right aspect, we can dramatically reduce all the bigger maintenance cost. So now switching on the hot stamping is another process you know very well, is quite recent, or is not so recent, but is coming back from the past as an alternative technology of forming of high-strength sheets. As someone said before, also aluminum, of course, is more and more used in the cars, but we we can see that big car producers expect also a very big increase of this kind of forming. So I think you know the process is a hot forming and quenching, so it's a hardening in the mold directly. It's very demanding for the mold, and I will try to explain now why. And it's mainly used for the most critical parts. So, for example, the A, B pillars of a car, and in general, parts very complex and with very high resistance is needed. So it's not so easy to form with a conventional cold forming technique. This is an example of the part in the car. This is the tool, which is composed by different segments. I will go a little more deep in the next slides. And this is a final produced part. How also in this case, how we can improve the total economy? Of course, to have a predictable tool performance, reducing of cycle times, superior end product intended as a quality of the final end products, improved tool production, and the service offered by Uddeholm. So as we said, environmental demands also in this case are increasing. Less emissions means lower weight, and lighter yet stronger components are needed. Some data coming from some research, the reduced fuel consumption using this technique can be around 30–35% in the weight, and also thanks to the use of few structural parts in the car. Regarding the safer vehicles, thanks to the higher strength, it's possible to achieve better results in the crash test, for example, and also the ability to create zones in the part with different strength, okay? And then we can see also the tendency to join together metal sheets of different strength on the same component. Of course, these are very important aspects, as to produce a car, it takes about 1,500 tools, not only for the car body dies, but also for plastic and for hot work. But 1,500 tools are a lot, so if we can optimize every of these tools, you can imagine for each new car model how will be the advantage. As we said, the hot stamping is very demanding, so we need a lot of properties in the tool steel. First of all, the temper resistance and the hot yield strength to maintain the hardness and the wear resistance and the strength at high temperatures. Then we need thermal conductivity in the mold to reduce cycle times, and these two properties are not so easy to obtain together. Then we need ductility and toughness to avoid the heat checking and the propagation of the cracks. So we need very good mechanical properties on the steel to avoid the gross cracking. Then we need wear resistance to have a longer tool life. And also in this case, normally to have a wear resistance and a very high ductility and toughness is not so easy on the tool steel. Also, if now with the recent materials, it's possible to have a very better mix of these properties. This is an example of a sector for a hot stamping die. As you can see, it's full of holes, very close to the surface, about 10 millimeters from the surface, and you can imagine the surface at about 900 degrees during the stamping, and the cold water running in these channels very close to the surface. So it's not so easy for the tool steel to support this environment. The contact pressure also is very important to have the good heat transfer. So the surface of the steel is very loaded. Our offer for this field, for the hot stamping, it consists mainly in 4 premium grades, which are hot work grades. QR90 Supreme, Unimax, Divar, and Orvar Supreme. The mix of properties of these grades is different. QR90 Supreme is more used for the heat conductivity. Unimax is more for the wear resistance, as also at high hardness can reach excellent toughness levels. So it's very good to work at high hardness, also for tough parts. Divar is our best grade for the toughness, absolutely. And Orvar Supreme is a good mix of properties, let's say, in the average field. Another good point is that, as we said, we can offer services and support for other aspects. One of them is the welding. For many of these grades, we have TIG welds for the welding, and we can guarantee uniform hardness of the welded area and minimize the risk of cracks if, of course, the right welding procedure is followed. We can give a lot of support on this also. Then we can also be close to the customer with suggestion on surface treatment. Sometimes is night riding, but for hot stamping, I can see that is more diffused the PVD coatings. Night riding is more to increase the surface wear resistance and to reduce the friction between the sheet and the tool. But the coatings, both in case of uncoated sheet and coated sheets, with different chemical analysis of the PVD, we can decide to stay more on the abrasive side. So the first time, the first case, or more on the adhesive wear resistance for the second case, for another type of PVD coating. Then normally just after the hot stamping, there is the trimming dies, and here the situation is similar to what we said before with the cold forming. So we have grades with a very good mix of abrasive and adhesive wear. Vanadis for extra is the excellent choice for this case, maintaining also a very good value of chipping resistance. Then we have Kaldai with the best in chipping. Then we have Sleipner, and which is a good medium mix. And all we can compare with the standard Werkstoff 2379 grade, which is good normally for abrasive wear resistance, but is typically very bad for both adhesive wear and for chipping resistance due to the very uneven microstructure and bad microcleanliness as well. Then some other offerings from Uddeholm is global service of presence, delivery service, technical support, heat treatment services, and tool failure analysis in our lab. Every year we send hundreds of broken tools in Sweden to be analyzed. So our colleagues know very well tools and broken tools and why they break and how to improve, of course. And then we can also give support on machinability, and both in the annealed condition and in the hardened condition, which is more and more common, of course. So at the end, to resume, just to go in the concept of the iceberg, For hot stamping, Uddeholm can help to have predictable tool performance, reduction cycle times, superior end product, improved tool production, which means improved total economy. At the end, the end user will have the biggest final benefit. Some other few numbers for Uddeholm. We are serving more than 100,000 customers in the world. Our sales network comprises of more than 2,000 people. We have a unique inside tool and die market. Uddeholm is producing only tool steels. So it's focused in this production for plastic, cold work, and hot work industries. We have more than 100 stock locations for fast and reliable deliveries. We have heat treatment in some countries, not all. For some other cases, we have a relationship, and we can anyway guarantee good performance. And global support from specialists. So our aim is to give you a competitive edge. On our website, you can find all the brochures and all the material, both for more marketing in this case, and also more for technical, very deep in technical brochures. Thank you very much.
Thank you very much, Riccardo. According to the fact that we have some extra time, some additional question or comment on the presentation? Please, Blush, maybe.
Thank you. Okay, I will be, yeah, it's for the presentation.
Maybe you can try this one.
Okay. Blaž Nardin, Gorenje. Just a question to Mr. Tonerer and to our friends from Uddeholm. I have two very difficult questions for you. One question is new materials. You were saying lightweight materials, aluminium. Is it also tailored blanks, rolled blanks, foamed materials? Is this also the strategy for Magna or not? This is one question for you. And also, maybe how can you tackle this information? Because everybody is talking about the reduction of CO2 emissions. And I'm a little bit worried because maybe, from my perspective, maybe the production of those kind of materials means higher CO2 for the production. I don't know how is the balance altogether. And the second question for Mr. Tonerer is servo presses. Should the tool makers invest to the servo presses, because you said no tryouts in the future on the spot by the customer? That means we should have the same presses as our customers. Thank you.
You can go for the first, or regarding the CO2 emissions, we just produce tool steels. We are not producing the high strength sheets. So we are speaking about how to form. So honestly, I don't know which is the environmental impact on the production of high strength sheets. Maybe we can ask to the producers. From our point of view, Uddeholm is working every day to improve their production from also the environmental point of view. In fact, very recent changing in the production. I've seen some natural gas using for the production of the steel. And also the use of electricity is changed and optimized in Sweden. They are historically very, very careful on this aspect, our colleagues in Sweden.
Yes, to the second question. Servo presses. I think it makes sense that we have also the tryout phase.
You need to use the microphone here.
Okay, once. Okay. I think zero prices are really good performances, and we can work with zero prices in all areas. So we can manage the speed in all the time. And yes, we can give simulations of these movements of the speed to the tool and die developer, to the tool and die maker. But it is also makes sense that we go when you think about new tryout presses. Servo presses can simulate a hydraulic press, can simulate mechanical press, and also then the typical servo features. And I think it makes sense that you think when you invest in tryout prices about servo presses. It's my understanding. Yeah. Invest. When you have to invest, you should invest in the right direction. Yeah. For the special tailor blanks, yes, we work on, especially on premium cars. We have to use it, but I think it's not. It's the processes are too expensive in this time, and also the processes to come up with the blanks, but also then when you have the manufacturing process in-house to form these parts, it's not easy. So I think also that we talk about hot forming. Hot forming is, for my understanding, for the next 10, 15 years thing, but I think the hot forming is also moved to more partial heating processes, not to full blank heating processes. It's too much energy what we lose, and I think that's we have the process to speed up. The process is too slow in this time. They can, so it's too expensive. But in this time we have no other idea to form this high strength steel. No?
I don't know.
think. Yeah.
Maybe just one short question additionally for Riccardo.
Yes.
You haven't mentioned the borderline between cold fabrication and hot fabrication in your presentation in a function of the yield stress. Can you tell us what is, let's say, according to your state of the art know-how, what is left, what is right?
On my knowledge, also with the hot stamped sheets, they can reach around 1,600 or 1,700 megapascal after the hardening. So the sheet metal is coming at 900 degrees in the mold, of course with a low mechanical properties, and after this forming and in mold hardening can reach the desired strength. So it's totally different process. The cold format is more or less the same area of hardness of the metal sheet, but is totally different. So what I can see is that, of course, the cold format today is more and more diffused than the hot stamping. Car producers are thinking to go in the direction for some parts of the hot stamping to reduce problems of the complex shapes. But it's not a matter of difference of resistance. The resistance more or less is the same. We can cold form also 1,500 megapascal sheet. Yeah.
Thank you. All right, so we completed this session.